Hello, hi. Yeah, I just did this code challenge on LeetCode, and I kind of like, uh, I don't know, this question popped up, and I'm a little bit like, like, what do you call this challenge? It's the product of array except self. This is a very complicated algorithm. I mean, this is a very complicated question for some reason. I don't know why, but basically it's saying that given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums of I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. That is good, so we don't have to do a safe int check, to prevent any kind of integer overflows. So that is a good, because if I have to code that safe int check, is going to be it's kind of a pain in the ass to do that. So you must write an algorithm that runs in O(n) time and without using the division operator, which is whatever, but it's difficult to do this for some reason. And I wish I can see the solution to it, because I want to know exactly what kind of approach that they use for this. But anyway, I wrote this algorithm. I ran some test cases. It seems to work. So basically, you have the input and you have the output. You have the input and you have the output. Blah blah blah. So you have constraints in here that are built into the solution. But there's various properties to this thing. So it's saying that the easiest way to solve this problem is to say that you take the product of all of these numbers, and then for the increment that you're looking at, you take the total product and divide it by the value in the increment, right? So like if you take the total product of this, you get 24, and for position 1, 24 divided by 1 is 24, 24 divided by 2 is 12, 24 divided by 3 is 8 and 6. So that's and 24 divided by 4 is what do you call it? Oh, I didn't know I can Google like this. It's cool. Yeah, I'm gonna remember this. That is so cool. You got this tab that can Google things for you. Cool. But anyway, so this is the basically the easiest way to do it, but they're asking you to do it without a division operator. So you have a couple of choices here, and basically if you do if you don't have a division operator, you have a choice to create a division operator, which is like a recursive subtraction, but the fact is that the division operator is going to be complicated in the sense that what if you have a divisor of 0, what if you have a divisor of negative numbers, such and such. So you have to create the rules of signs and stuff like that. So you can work your way to creating the divisor operator. So it's going to be a little bit complicated. Just thinking about all those kind of case scenarios of the divisor operator, it's much more complicated than it sounds. But I've been trying to find like an algorithmic solution to this problem, and basically what I've done is I took a look into this array as you got, and I was trying to find some sort of pattern that I can use algorithmically to try to use some sort of in place kind of solution to it. So basically the way I look at it is that in this array set, you're taking any number of n-1 elements and you're multiplying it together, and it will turn out to be within a position in your output. So let's consider the first 3 values out of 4 values, right? So you have 1, 2, 3. 1 times 2 times 3 is equal to 6, and you see 6 is equal to the last element here. If I take 1 times 2 times 3, and let's say, how about I shift the element, so I do 1 times 2 times 4, that equals to 8, right? And then I can do like 1, because I did 1 times 2 times 3, then 1 times 2 times 4. What if I increment this value now to 3? So I do 1 times 3 times 4, that equals 12. And then finally, I go through 2 times 3 times 4, which is equal to basically 24. So that's basically the solution that I'm trying to come up with. So I'm trying to basically work my way up to finding the first three values within the array, and basically take those values and multiply together, and then you can assign it to the last value of the element. Uh, so that's the iterative solution that I've used. So thinking about it like that, like the easiest way I can create a base case scenario is just create it, right? But there's a problem with the algorithm that I've written. So basically, although my code is right and everything like that, the time complexity for this is actually is going to be like the time complexity for this one solution is O of n. So let's do a summation of each element, right? So you have let's say this one takes O of 1, right? This line takes actually is deceptive because create increment is actually going to run create increment in here is actually going to run n minus 1 time O of n minus 1, right? This one is going to take, it's an assignment, let's consider it a constant, O of 1. And within the for loop, you have a product of the output. And I created basically just a product function that will take the product of two elements. Basically, it will take the array of nums and the array of increments. Basically, what I've done here is I've generated a dynamic increment. So like if you have a dynamic array size, like you might input like an array size of 4 or an array size of 5 or 100. Basically, I will create the increments array to denote like the first three values out of 4 elements. Like this would be the starting point, right? And so basically, what I would do is that I'll work my way backwards and say the last element, and I'll shift it one value over. So first value is going to check 1, 2, 3. The second value of the iterator is going to check 1, 2, 4. So it's going to go work backwards in increments and shift basically it's like a bit shift or something, and then it's going to be like 1, 3, and 4, and then 1, and then 2, 3, and 4, basically. So once it works its way backwards for all the values of the 3 subsets out of the 4, whatever, and it's going to go ahead and basically shift its way that way to and combine basically the 4 value num and just multiply those values in those position together, basically. So this one runs in n minus 1 time, and this one, the product of it, basically runs n minus 1 number of times, right? So n minus 1. So this one is the tricky one. This one is actually going to run n minus 1 times n here, n times n minus 1. So this is the problem with my algorithm. So this is not perfect. It's not really conducting the steps in O(n) time. Because of that, I have this problem. So once it reaches the last element, I create a break so it doesn't go to the array index. But if it's basically this loop is running backwards, because if I take the first 3 elements in here, you'll see that it creates the product of the last element in the output. So I'm working my way backwards in the output, and I'm assigning that output to the product of the values. Okay, so the product of the value will take like a cross match between the array increments, like position 0, 1, and 2, and it will match it with the num arrays for those values and product them together, basically. So it's like a cross apply union of the operations and like multiplying together, so it's taking those 2 sets and like crossing them over to create the match case and multiplying them together. And this is the problem. So I'm trying to reduce this algorithm to like not have a total problematic that this is actually running n squared complexity time. So this is the difficulty of it, and I just had a thought in my head when I was like making this video how to reduce it, and I'm trying to remember what I was gonna do. So basically, I was trying to think of a way where I can take the elements between. So the challenge here is to take the elements within array and create like a new subset of that array, right? And when it comes to these kind of coding challenges, the difficulty of it, like without working with an ID, is that you cannot use any kind of IntelliSense or any kind of other thing, so you're kind of stuck on like this really fundamental algorithmic approach. So understandable for data structures, but so my thing here is like trying to come up with a solution that can reduce this value. So creating increments here, you know, if there's a way that I can take the subset of the original array within positions 0 and n minus 1 and multiply that together, and then as I'm working my way through the increments, I shift the value of like n, you know, and then omit a value and then take that value. Like, this is a little weird. So but this is not necessarily the problem. It's really just cross-matching the product that's creating the issue here. So I'm actually like stuck on this because I don't know how to do this in any other way, and I'm kind of out of options. So I'm kind of curious to see if anyone else has come up with that ON solution without using the division operator. This is a interesting question. So that's my thought process. So I run the code, I run this input, it works. I strayed away from creating the divisor function because I thought that the divisor function would be like it's going to be much more complicated than anything else. So but if I run this one as well, this one also works out. But yeah, I'm kind of stuck on this. Like, I don't know how to make this one any better. So like, does any other test case work here? Like, I don't know, 99, 1, 2, -5. Does that stuff work here? Can I do a test case like that? Nums must consist of values from, oh, okay, -30 to 30, so I can't use 30. Okay, 29 then. -29. Yeah, you know, run it. Run it. So yeah, it works. It works. It works. I don't know, man. It works, but yeah, like, I'm stuck on this. I don't know how to reduce this one. So this particular issue comes with this product that I created. And if I can, let's say, cross these two arrays together, which is not the worst case. Like, can I do that? Like, it's like something. Yeah, and oh man, it's like something I gotta do. So I don't know, man. I don't know how to do this. But fundamental data structures, damn, I don't know how to do this in any other way. Like, yeah, you can do the like, if you can use the divisor, like, then you can do it in ON time. But if you think about the division operation, right? If you think about repeated subtraction, the repeated subtraction method or function will run in another iteration, right? Of a particular size. So that's the complexity thing going on. I don't know. So like, but that might be negligible. So I think that's actually the only option here. So the only way to create this in ON time really is to create that division operation in a recursive function. I think, yeah, that's the solution. If you want to do this in O(n) time, I guess you have to use the divisor operation. So the division operation in here, repeated division from this value by this value, it would be like 24, but like in the case of large cases, because you're bound between size 30, your division operation, and since you're using an integer, your max time is actually a constant for your division. So your max runtime for division is a constant of 30, because like the worst case scenario, 30 divided by 1 is 30 because of these constraints. Because of these constraints, then technically you would your division operator would run on a constant time. Because it would run on a constant time, is going to run in O(n) time. So this is actually the only solution here then. If you want to, the correct way to do this in O(n) time is to create that division operation. So I did it like this, and I guess it's not right. And it's good enough, but it's not really perfect. So yeah, I give it a shot, and yeah, I'm gonna go ahead and cut it from here. So yeah, so this is a little bit tricky. So they said you cannot use division operation. It would make it really easy to do this. But if you cannot use the division operation, what you really need to do is develop that division function. So you have to create that recursive division operation to the repetitive subtraction and creating all the rules within those repetitive subtraction. And if you do that, you would get the right answer. Then it will be easier. The rest of it will be easier then, instead of trying to do what I did just now. So like that would run in O(n) time, given the considering that the division could be like considered a max constant. So it's not probably the worst thing here. So it's going to be like C of n. It would reduce this to a C of n. So this n minus 1 would be reduced to like a C value. If I had like a division, product divided by division. So the total runtime of that algorithm is going to be like O(n) to n to create the product, the total product, and O(n) plus n times C, constant of the divisor, which is basically equal to O of n if you create the division operation function, right? So that's basically it. So I think that's it. Like, it's a little bit tricky, but yeah, and I talked too much, so I'll cut it off here. Oops.